Question 6, there's questions about compounds of group 3 elements. Aluminium will combine directly with fluorine. Write the equation for the reaction between aluminium and fluorine. Now be careful with this one. Your chemical formula of fluorine is F2. All right, fluorine is one of the diatomic molecules that we've got on the periodic table, or diatomic elements we've got. So all the elements that exist as two atoms combined. So all of group 7, all of the halogens exist as diatomic molecules, and other examples are hydrogen, which is H2, oxygen, which is O2, nitrogen, which is N2, and all of the halogens, all of group 7. So if you fail to spot that, your equation will be wrong straight away. So, reaction between aluminium and fluorine. So aluminium plus fluorine, F2, will produce aluminium fluoride. So you've got to think about the ions that would form here. Aluminium is in group 3, so it would form a 3+ ion. Fluorine's in group 7, so it would form an F-1- ion. So your formula here is going to be AlF3. 3+ on the aluminium, 3 lots of 1- for the fluorides. There's your formula of aluminium fluoride. Now that's part of the question done. You've got to balance it, even though it doesn't say write a balanced equation at A level. Whenever you're asked to write an equation, it is assumed you're going to balance it. So you have to balance it. 3 fluorines and 2 on this side. So I can cross multiply those to give me 6 on either side. So if I put a 3 there and a 2 there, that now gives me my 6 fluorines and 6 fluorines there, 2 aluminiums and 2 aluminiums there to finish that one off. The next question, a compound of thulium, atomic number 69, has the following composition by mass. So there's your values there. State what is meant by the term empirical formula. No excuses for getting definitions wrong. It's just a case of learning a sentence. Empirical formula is the simplest whole number ratio of atoms. Whole number ratio of atoms in a compound or in a molecule. Okay, you must make sure you refer to the simplest whole number. And then the calculation to determine the empirical formula of the compound. Now lay these out nice and logical, like a table. Remember it's a ratio. Okay, oxygen, we've got 30.7%. Sulfur, we've got 15.4%. Thulium, 53.9%. And your 3-step process for working out an empirical formula. Calculate your number of moles, divide by the smallest, and then if you haven't got whole numbers, you have to scale. You cannot round those numbers up unless they are quite evidently very close to the whole number. All right, you must always scale. So let's do that process. Moles, smallest, scale. So number of moles, divide each of these by their atomic masses, their molar masses. So oxygen is 16, sulfur is 32.1, thulium is, doesn't tell you in the question, so you've got to go to your periodic table. Let me just check on mine behind me. .168.9, so it took me quite a long time to find it then. 168.9. Okay, work these values out, and you'll get your number of moles of each one. And you would get 1.92. For the sulfur, you will get 0.480. And for the thulium, you'll get 0.319. So then you need to divide each one by the smallest. The smallest value here is clearly the thulium. So divide all of these by the smallest value. Okay, and you will get your simplest ratio. So that's going to be 1. That comes out at about 1.5. And this one comes out at 6. Now you've got here 1.5 sulfurs. So this cannot be rounded up to 2. That means you've got to scale the ratio up to the simplest whole number. So if I multiply the whole ratio by 2, that then gives me 12 to 3 to 2. And that will be my simplest whole number ratio. So if I double that ratio up, that's going to mean it's going to be O12, S3, TM2. And there's your empirical formula. Does not matter which order you write these in. You can write Tm2S3O12, you can write Tm2O12S3, doesn't matter as long as the values are correct for the different atoms.